Hi there, welcome back to the channel and welcome to the second and last video in the restoration of this Nordmende Skandia V24. This is the second one I'm doing. This was a mini project for someone who wants to offer this restoration to his sister as a birthday gift. So I'm happy to say that it's complete. A few little challenges along the way, especially on the use of Bluetooth on this. Everything else, not so bad. But in this video, I'll show you what was outstanding and what I did here. I did the component changes. I did the IF and RF alignment for the AM bands. FM was pretty fine as it was. It was actually very, very good. And then, of course, the Bluetooth. And the Bluetooth was the one with a few challenges, which I go into in a little bit more detail. So if this sort of thing interests you, stick around and enjoy the video. Just as we had with the previous Skandia project, the components that needed changing are fairly few. It's all these caps over here. You can see them all in yellow. So there's 1, 2, 3, 4, 5, 6, and an electrolytic down there, which is the cathode bypass capacitor for the output tube. So all these were replaced, nothing new there. There's 100 picofarad over here. And other than that, everything stayed exactly the same. And I did, of course, do something about the filtering and the selenium rectifier. This is absolutely identical to the previous one. I put two capacitors on my little board, you know, the little round board that replaces the cap. The cap at the top is completely disconnected, but it stays there just for the looks. So the two 47 microfarad 450 volt caps over here. The little board here with the silicon diodes creating a bridge required some resistors. This is 280 ohms, so it's two 560 ohm resistors in parallel. I checked the voltage at this end. It came out just below the spec voltage. And so that keeps it a little bit cooler, but it's working fairly well. This part of it I didn't do on the previous project, so I had to go back and change that. But on this particular one, it's all done. I haven't used the new boards yet, which I've ordered. The ones I've ordered have a few slight changes on here, and I'll be showing you that shortly. So as far as this is concerned, everything is perfectly fine. And then I tested the radio and everything works. So that part is done. That was the first task I mentioned in the last, at the end of the last video, that I needed to replace all these components. There is one more capacitor at the top, and that is that guy over there. That was a safety cap. They had 6.8 nanofarads. I had 4.7 available, so I used that. It's not a big deal. So all component changes have been achieved, and so that stage of the project is complete. The next step in the procedure in the project was to do an alignment. Now the first thing I'm going to do is an IF alignment of the AM bands. I think the FM is perfectly good, but we'll check that at the end. But the AM, I certainly want to do an alignment, and I'll do the IF alignment first as usual. So as per usual, I'm going to feed a signal into the grid of the ECH81, and I'm going to measure the output. It's going to be a modulated carrier at 460 kilohertz. That's the IF frequency. And I'll be measuring the output and peaking these coils. It's this one here and the one below, that one there and the one below. See if we get any improvement. So here goes, 460 kilohertz carrier, minimum amplitude possible. It's modulated, AM modulated, and it is 30% modulated, and I'm feeding a 600 hertz tone just to make it slightly less annoying. As usual, I've got that coming into the stepped attenuator, switch attenuator. That comes out of here, and I'm going to leave it at, I think the last time I had 18 dBs of attenuation. I've got it coming in here directly into the grid pin 2 of the ECH81, and the other side of the signal generator is connected to ground. The speaker's connected. I've got it on speaker at the moment. I can then flip it to load so I don't have to listen to it. And I've got these two wires coming up here to the AC millivolt meter, which we'll use to do the alignment. So let's get cracking. So as they tell us to put this on 1650 right at the end. Select medium wave, put the volume up, and we should hear it on the speaker once it warms up. And here it is. I'd forgotten to activate the signal generator. So yeah, we can hear it pretty well. I think I'm going to give it a bit more attenuation. Another 3 dBs. It's probably still too much. Let's give it 24 dBs of attenuation. You can still hear it pretty well. I don't want to have to listen to that, so I'll put it on dummy load. And now we can watch the meter. I'll put the volume up to where it's halfway. As you can see, I'm just touching the volume here. And we will adjust these two guys. No. I think it's perfectly peaked. That one's peaked. I don't think I'm getting any change here. Let me turn this around so I can get on the underside. Got to be careful, this thing's on. Now we need to make sure we get the right ones. It's the top two. This is one of them. That was peaked. Here's the other one. Well, that was anticlimactic. I don't think I got anything better out of that. So the IF for AM is aligned. Let's have a look at the RF alignment. Now to do that, I need to put the dummy antenna on, and I'll connect the antenna straight to the AM antenna signal here. That one there's ground, so I'll leave that as ground there. This thing is perfectly set to the end there at 515 kilohertz as instructed. So we know that the dial pointer is in the correct position. And they tell us to set the signal generator to 555 kilohertz. Still with the tone. Put the volume up and come to 555. You can just hear it there, but I'll give it a little bit more amplitude because this is going through the dummy antenna. There we go. Therefore it's getting attenuated. I'll leave the tone on so I can... It's just out. You have to look straight on to get it, but it's just out. It's a couple of millimeters out. And we know that to adjust the oscillator, we need to play with L44, which is here. Which one is it? It's the one away from here. It's this guy over here. This one over there. Yeah, let me move it towards 555. It's perfectly on 555. Now I'm looking straight on there. So we've got that perfectly aligned. And to get the front end, we need to adjust L41, which is that guy over there. Now for that, we need to look at the meter again. And I'm going to put it on dummy load so we don't have to listen to it. And I'll put the volume up. And now I need to move that coil for the highest amplitude, but I can't touch it because if I touch it, you see that meter? So I need to move the coil very carefully. Oh, that's nice. So it did need some adjustment. It's going down. We go the other way. That's a peak. At the end of this, I'm going to just drop a little bit of wax on there, make sure that that stays in place. So that front end is perfectly aligned for the medium wave, which is great. Well, actually, no, that's just for the front. That's the bottom frequency of the medium wave. So let's go to, what's the next one? 1480. So 1480 kilohertz. And the volume up. Let's get the speaker back on. Go to 1480. Man, that's right on there. That is right on there. You see that little notch? That's exactly a 1480. So I don't need to play with the oscillator there. And the front end is C21. So I don't need to play with the oscillator capacitor. I just need to adjust C21. And C21 is at the top here. Now again, we should look at the meter, which means I need to get some volume. I'll turn the dummy load on again. Okay, volume's up so we can see the meter. And C21 is, actually it's the one I did incorrectly last time. So the last time I think I did this one by mistake. Did I? Which one is C21? It's this one here. Now that's the front end. Oh, that's nice. That got quite a bit out of there. Watch that. There it's peaking. That's a peak. That needed a bit of tuning. Good. So the medium wave is completely done. Brilliant. Now we've got to do long wave. I'll put the sound on again. Select long wave. We need to set the signal generator to 210 kilohertz. So 210 kilohertz. And we tune to 210. Now where's 210? There's a little mark over there. It's a little bit out. I believe that's where, hang on, 210, no, it's on. 200, 10, 20, 30, 40, 50. It's just slightly out, so I need it there, it's actually there. And I need to change oscillator as L41, and that's on the underside. Damn, I don't want to mess this up. That is, where is that guy? You know what? I can't see a hole for that. That is really strange. There's no bloody hole for that. Oh, that is just nice. Well, you can't really adjust the... Am I seeing correctly? I'm looking at the back here and I've got two holes. One there, one there, one there, one there. And where is that guy? Well, it's probably underneath the switches over there, and I'm not going to mess with it. It is so close that I'm not going to mess with it. And sometimes that's what you have to do. You need to leave well enough alone. And I'm going to optimally tune it. Get the volume up. Put it on dummy load. We can watch the meter. And now we need to adjust L24, which is, yes, you guessed it, this one over here. Now again, I'm going to do that without touching it. This is insulated, and I'm going to try and peak that. Would that go in? See, if I touch it, it goes everywhere, but I don't want to touch it. What am I going to do here? Let me just do a little bit at a time, see if it improves. It's sort of on, what is that, 6? That's getting better. How can I do this? I'm going to hold this in place here, and I'm going to push that guy there. Oh, see, I can't go near it. If I do that, I'm adding to the field strength and messing up the core. I've just reduced the volume so that I get this in the middle again, and I'm going to push it slightly. Yeah, it's improving. Oh, it's getting a lot better. Let me take the volume down again to middle. Do a bit more. It's actually going down, so that seems to be the best place. So we have aligned the front end of the long wave, which is those two are the most important ones, long wave and medium wave, because that's where the coils were replaced and the core was broken. So that has been done. Now we need to do the short wave, and the short wave is at 6.1 kilohertz, 6.1 megahertz. So 6.1 megahertz, and we'll see if we can hear anything. It would help if I took it out of dummy load. Where's 6.1? It'll be down here. Whoa. It's pretty much spot on, but I can sort of improve it a little bit. It's that core over there. Now it's this one over here. So I can sort of ride this a bit. I need it on 6.1, which is there. So I'm going to put it just at the edge, and I'm going to follow it. Yeah, twist a bit more. A bit more. That is exactly on 6.1. That is spot on the little dot over there. So 6.1 is done. And now they tell us that the front end is L11, and L11 is on here. And again, we have to look at the meter. Let's give it some volume. Put it on dummy. Let's give it some volume. Okay, we've got it down the middle. And L11 is this one here. This one here. It was peaked. There's the peak. That's perfectly aligned for the front end. And then they tell us to go to 17.9. So 17.9 megahertz. And we'll tune here, get the dummy off. Go to 17.9. It's a little bit high, it's on 18 point something. See that? 17.9 should be about there. There's 18, it's at 18 point something. So I need to adjust C11. Is that right? Yeah, C11. C11 is back on here, and again I've got to ride it a bit. So I need to sort of ride it. I'm moving it towards where it's supposed to be, and I'm going to this is really stiff. I wonder if that core part is grounded. Yeah, it is, so I can touch it with a metal screwdriver. It's picking something up. No, I got that wrong. I got that wrong. What they tell us is that you can't align the oscillator at 17.9. You can only align the front end, and that's what that capacitor's for. So let me tune it optimally again. And I give it some volume, and I'll put the dummy load on. Let me get it to the middle there. And this thing is just for the front end. Makes sense, it's at the antenna. So let's see. Goes up, starts going down. So that's peaked. Okay, good, good. And here's the final stage of the project, the Bluetooth. Now, this posed a few challenges. Let me just explain. When I designed this board, this is the second version of the supply board for the Bluetooth module, and I'm using these modules. And I've actually indicated to quite a few people what module it is. Oh, the cat's here again. And I wanted to keep this module because I really like it. It's small form factor, it fits nicely on here. I could change the board for other modules as well. I could take the leads to other modules, but I like this one. So I designed this board, and I did something which I'd been wanting to do for some time, which was to add some gain. Now, the reason is when you feed the signal coming out of here into the phono input at the back so that it activates Bluetooth or uses Yeah, okay. You don't agree, fine. So that it uses this signal coming out of the Bluetooth module into the phono, the signal level is too low. So what I did is I designed this section, which is just a it's basically a dual op amp gain stage with an adjustable gain. You can change the gain based on the two resistors that you put in here, these two resistors over here. And I had to design this supply very carefully because it has to be referenced to the output ground so that it doesn't introduce noise. Now, there's actually, this is a strange situation. There are two sources of noise when you use this thing. One of them is audio noise, which actually goes into the audio if you don't have the supply completely isolated from the radio. And that's why I use this DC to DC converter over here. So got rid of that. When I select phono, there's absolutely no noise. The other noise is actually picked up by the antenna, the internals of the radio. This Bluetooth module produces noise, and especially on FM, you get a buzz. So when you're listening to FM, you can hear this. Now, I've used this board on various radios before, the bigger ones especially, and I don't get any noise at all. But these things are fairly small. These radios are fairly small, so everything is pretty close together. So the idea is that you actually switch this off when you're not using Bluetooth, when you're not selecting phono. And ideally, you get that done automatically so that you don't have to sit and toggle a switch at the back. The easiest way to do that is you take the ground lead, the one that's supplying ground, which is basically chassis. This is from the 6.3 volts AC supply, the heater supply, and you just disconnect that or connect that depending on whether you need it or not. Now, I've found various ways of doing that. You can put a switch of sorts so that when you plug in, when you pull in or push in the phono selector, that contact is made. So this board is supplied. So you have Bluetooth. When phono is not selected, this thing switches off, which is just fine. I couldn't do it on this one. This thing, to activate phono on this, you have to select two switches, which is long wave and medium wave at the same time. And there's another problem. There's very little space in there, but I'll get to that in a second. The other thing that I had to, or try to change here is I used an NE5532 op amp. This is actually a suggestion by another YouTuber who had problems with the LM358. The reason I use the 358 is that it's a rail-to-rail. And because I'm using the 6.3 volt supply, I'm not getting a very high voltage, positive and negative voltage here. It's actually something like 7 volts. So I used a rail-to-rail. I used the LM358 in the initial designs. But he found that at low levels, this thing actually has some crossover distortion. And I've checked the datasheet again, and it does say you should not capacitively couple this to the next stage without a resistor to ground. I could have done that, but I found it easier without changing the board just to drop the gain a bit, because this thing, when I put it in here, it doesn't go rail to rail, so it was actually clipping when I had 47K over here, which gives me a gain of 4.7. So I dropped this to 33, no clipping, and the level's still fine. I'll have to rethink this, and that's one of the reasons I need to rethink this. What is this guy doing here? Okay. And the other reason is I need to find a way to get this thing to switch on in this board, probably using the Magic Eye, because the Magic Eye is deactivated when phono is selected. So I'm going to rethink that. And for this particular project, I'm not going to change. I'm not going to hack this thing. I'm just going to put a little switch at the back. I didn't want to do that, but I found it's the easiest way to do that. And I'll show you why. This is the switching arrangement. And the problem is that the bottom of the radio is actually pretty close to those switches. So I don't have much space. And I could have used the fact that these things go down. They go down about, I don't know, 5 millimeters, 6 millimeters when you select them. And I could have put some sort of switch on here that makes and breaks depending on how I push this, or even on this itself. But there's no space, and I didn't want to hack this thing and have all sorts of contraptions hanging around here. I want to make this as original as possible. The other possibility was to actually use these switches on here, probably the long wave. There's actually one switch set here which switches on off the Magic Eye, but they work opposite. So when I select long wave, it activates Magic Eye power to the Magic Eye for the medium wave band. And when I select medium wave, it activates it for a long wave band. So to have this thing operating on long wave, which would have been the least obtrusive, it would switch on the Bluetooth with medium wave selected, which is not what I wanted to do. So again, I looked at various options and I decided it's the best and the cleanest way to do this is to put a little toggle switch at the back. It's just something that you switch off when you don't want Bluetooth, you switch on when you want Bluetooth, and then you select Bluetooth by selecting those two together. Not ideal, but it's the best I can do until I've changed boards and everything else, and I don't know when I'll be able to do that. So this is ready to be used. I've got the Bluetooth in here, ready to put it on the radio itself. As is usual, it's going to be soldered to the back of the phono input over here. And then the supply, I've taken it from one of the heater connections here on the output tube. I'm not sure whether that's the best way to go. I'll probably do it to the dial lamp. And then the ground over here will just go through a toggle switch to ground so that I can operate this thing. So this thing is done. This thing is completely done. All I need to do is put it into the cabinet, and let me show you the cabinet. The cabinet had very little wrong with it. There were a few little dents on the edges here which I filled in and polished, and the rest was just a question of washing it down and polishing it with furniture restorer, and it's come out fairly well, actually very well. So I'm pretty happy with this. I did the usual polishing of the logo and the logo there. This thing was loose, so that was stuck in place. And really that is it. There's not much to it. You know, the inside got the new tape on there. Cleaned the speaker. These were perfectly tied down. Everything was cleaned up inside here. And this is ready to receive the radio. You can see there's very little space underneath here when I put that radio in, so any switching would have been practically impossible. So what I'm going to do now is I'm going to get the radio off the jig, the mounting jig. Somebody's named it for me, thanks. And I'm going to put this side by side and see how best to wire the Bluetooth, because I want the Bluetooth module somewhere down here. All right, let me get cracking. All right, folks, we're done. We are done. I have the switch coming out the back here. This will just go through one of those holes in the back panel. It's very neatly wired and zip tied to the wire going to the dial lamp. I think you may be just able to see that there. So this is, I've given it enough length so that the back can come off, but not too long that it gets in the way. The board is firmly in place with 2 spacers and screws, one on each of those ends. I didn't need to do the other 2. This is fairly firm. Speaker's been, the solder connections cleaned, and this is resoldered on there. That's just a better view of how I connected this to the dial lamp. I've got some zip ties on here. The wire's going around the front so it doesn't come past the hot output tube. So we are ready to close this up. Here's our back panel. Now this goes over here. So I want the wire, the switch, to come through somewhere there. And it's just a matter of taking out the nut. And I don't need to widen the hole or anything. It just fits nicely, very nicely. Like that. I don't like making holes in these things. Making them is easy, but if you want to cover them up later, it's impossible. So whenever you do something like this, at least I do, I try to make it as reversible as possible. So if somebody wants to get this thing back to the original form, they don't find extra holes and damaged parts and replacements that cannot be redone or reversed. That's it. That is on. No, that is off. On, down. On, up. No, it's the other way around. I want down, on. So I just need to reverse this. So down, on. It's just a convention I use. Some people have different ones. On, off, right? On, off. Now all we need to do, you see you can still move this out, remove it. All we need to do now is fit this in the back. Yeah, that'll do. I've got an extra one of these. If you remember, there was one missing, but I've got an extra one, so I'm putting it on here. I want to see this thing complete. This guy deserves it. This radio is beautiful. Let me do this off camera. This is getting difficult. There we go. We're done. This is done. And now all we need to do is to test it. So let's do that. Got it on medium wave. It's early in the day, so I don't expect to get much. This is the local station.
A Escola Agrícola da Madeira. Um saber aliado à agricultura. A Escola Agrícola da Madeira tem ao seu dispor várias formações.
Canary Islands, as usual. Canary Islands again.
Los blancos y vamos en afición. Tienen unos y otros, por eso.
Now let me show you let's check the effect of the Bluetooth. I'll leave it in a quiet spot and I'll switch the Bluetooth on at the back. So down for on. I don't hear any difference. Doesn't do much on medium wave. A little bit more noise, I guess. Don't think we'll get much at this time of day except one. There we go. Does it affect long wave? Let's try that. On. No difference. Okay. FM.
Esta terça-feira, dia 9 de maio, em várias cidades russas, mas foram cancelados.
As cerimónias estão canceladas em dezenas de cidades, em várias regiões russas. Parece ser de que a parada do dia da vitória sirva de alvo a ataques.
This alignment is perfect. 101.6. This is the usual thing. I'm using just the internal dipole. But here, if I put on the Bluetooth, you can hear it. Really noisy. Now it's probably because I'm using the internal dipole. If I remove the internal dipole, let's try that. This is stiff. It practically disappears. Now I'm going to use the external dipole, and Bluetooth is on. There's no noise. Let me switch it off, see if it makes any difference. There's a little bit more noise. Just a little bit. But you see, you can actually decide if you want to use... If you use an external antenna, it doesn't really pick up the Bluetooth noise. The reason it picks up with that internal dipole is because that dipole is literally around the top here. So it's natural that it'll pick up any RF that this thing is creating. But there we have it. This is our radio reception. Now, as for Bluetooth, obviously I need to make sure the switch is down. I need to look for the MH-M28. And here we have it. Click it on. I need to select Bluetooth there, obviously. Let me show you that again. Disconnect. And if I connect it, you hear the connection coming on there. And now if we find some royalty-free music, if I've got any, let's see what that sounds like. course, I can try control the volume here. But this is set so that if I've got that on this on max, there's no clipping. Try something else. That is actually pretty loud when I put it on maximum. So this is a pretty good result for Bluetooth when used like this. And that, my friends, is really the end of this project. As I mentioned at the beginning, this was a special project done for someone who wants to offer this to his sister. He is offering her the restoration. She's going to get this radio. She lives in Portugal, so this should be quite easy to ship there without any customs issues. And I'm really, really glad I was able to do this. I'm sure she's going to enjoy it. And I'm sure that the fact that this thing has got Bluetooth, and you can see the blue shining at the bottom there, we can just switch it off here, will make this thing really useful, not just as a receiver. And it is a very, very good receiver, especially on FM, which is why I do most of the radios. FM is quite useful in Portugal. I don't know if it is where you are, but in Portugal, we still have a lot of FM stations. The medium wave, not so much, but I get a lot from Canary Islands. Long wave, absolutely nothing in Portugal, but I get some stuff from North Africa and I think from France. Unfortunately, we've lost the Irish one and I think BBC 4 as well. Not sure. Radio 4. But FM, yes, sounds really, really good. And of course, Bluetooth. And that's really what I think is the main focus of this particular set. They want to use Bluetooth. So for now, I'm going to thank you for your company. Hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon or PayPal. Links on the description below. Thanks for watching. Bye for now and stay safe.